My name is Tan. I'm a student of Curtin University and studying Bachelor of Information Technology in Computer System and Networking. This is the first of three videos in semester 2. For this semester, I'm going to do a smart garden system. Gardening is a very gratifying hobby. However, because of my busy lifestyle, plants in our garden may not always get the attention they deserve. What if we could remotely monitor their condition and give them the care they need? In this project, I'm going to create an IoT-based smart gardening system using the ESP8266. This smart garden project is a plant environment monitoring system that monitors soil moisture, air temperature, humidity, and water level. Then, depending on the condition, the system allows users to deliver what is needed remotely through a mobile app. Moreover, this system can be scaled and expanded to automate the entire gardening process. One of the most important things in this project is the processor. The ESP8266 is an amazing chip for on-home automation and IoT projects. The ESP8266 costs less than $5. It's even cheaper than the sensor launched out of Canon. It means the sensor Canon's use are usually made with low-cost approaches because it will be useless after Canon launch. Even though ESP8266 is still a lot cheaper than the sensor, being cheap is definitely a great breakthrough, as well as its high Wi-Fi connectivity, which is useful to monitor and transmit the data through the internet. Since more and more people knew both and tried using ESP8266, they found the disadvantages of the chip and tried to improve it. For example, to develop ESP8266, people had to understand FreeRTOS and cope with the professional C language. But an Arduino IDE plugin was then developed so that developers can use Arduino IDE to write ESP8266 common code to diminish the difficulty of development. The DXT11 is a basic ultra-low cost temperature and humidity sensor. It uses a capacitive humidity sensor and a thermistor to measure the surrounding air, and output a digital signal on the data pin to be easily read by a microcontroller. An F328 consists of a sensor module and a sensor. The sensor module mainly has an LM393 capacitor, potentiometer, and indicator LED light. Commonly red for power indication and blue for digital output. The sensor is a pair of test probes which are placed or inserted into the soil. The F328 module has both digital and analog outputs. The analog output A0 gives the direct analog value of the sensor reading between 0 to 5 volts. The analog output value is proportional to the resistance of the soil. Thus it will be high when the soil is dry, and the value decreases as it gets high. The function of the relay is similar to the electrical switch, which is controlled by a processor to open or close actuator in order to adjust the temperature, humidity, and moisture soil. Actuators are the most critical automation part of the project. Mainly, the microcontroller will collect and simplify the data from the sensor so that it instructs the relay to activate the actuators, satisfying the growing environment of plants. Specifically, actuators include a water pump, LED, fan, and heater. For instance, whenever the temperature is dropped down, the processor will activate the heater. Flex is a new platform that allows you to quickly build interfaces for controlling and monitoring your hardware projects from iOS and Android devices. Specifically, Flex support for creating a local Flex server, allowed to keep everything within a home network. This is useful for setting up a network in a remote location. or be concerned about the traffic going through or the machine is clogged. This is my timeline for my project. Thanks for listening. See you guys on next video.